Thermodynamics is the branch of science that deals with the study of heat and its relationship to other forms of energy. It has many practical applications in fields ranging from engineering and physics to chemistry and environmental science. At the heart of thermodynamics lies the first law of thermodynamics, which is a fundamental principle that describes the conservation of energy in a system. The first law of thermodynamics, also known as the law of conservation of energy, is a principle that states that energy cannot be created or destroyed, only transformed from one form to another. In other words, the total amount of energy in a closed system remains constant. The first law of thermodynamics is a critical concept for understanding how energy behaves in various systems, ranging from simple machines to complex biological systems. This video will explore the first law of thermodynamics in detail, examining its historical development, practical applications, and philosophical implications for our understanding of the natural world. Whether you are a student, a scientist, or just someone curious about the world around you, this video will provide a clear and engaging introduction to this important principle of thermodynamics. Before we get started, make sure to hit the subscribe button below this video and subscribe to our channel to be a part of our YouTube family. Thermodynamics is a branch of science that deals with the study of heat and its relationship to other forms of energy. It has many practical applications in fields ranging from engineering and physics to chemistry and environmental science. At the heart of thermodynamics lies the first law of thermodynamics, which is a fundamental principle that describes the conservation of energy in a system. The first law of thermodynamics, also known as the law of conservation of energy, is a principle that states that energy cannot be created or destroyed, only transformed from one form to another. In other words, the total amount of energy in a closed system remains constant. The first law of thermodynamics is often considered the most fundamental principle of thermodynamics. It is based on the observation that energy is always conserved, no matter what form it takes or how it is transformed. The law is a statement of the conservation of energy, and it is one of the most important principles in science. The first law of thermodynamics can be traced back to the early 19th century, when scientists first began to study the relationship between heat and energy. In 1847, the German physicist Hermann von Helmholtz proposed the concept of energy conservation, which was later developed into the first law of thermodynamics. The law was later refined and extended by other scientists, including James Joule and Rudolf Clausius. The first law of thermodynamics has many practical applications in fields ranging from physics and engineering to environmental science and economics. For example, it helps us understand the behavior of machines such as engines, refrigerators, and generators, which convert energy from one form to another. In an engine, for instance, the chemical energy stored in fuel is transformed into mechanical energy, which is used to power the vehicle. In a refrigerator, thermal energy is transformed into mechanical energy, which is then used to cool the interior of the appliance. In each of these cases, the first law of thermodynamics ensures that the total amount of energy in the system remains constant. The first law of thermodynamics is also important for understanding the behavior of natural systems. It helps explain how the sun produces energy through nuclear fusion, how plants convert sunlight into chemical energy through photosynthesis, and how the Earth's climate system maintains a delicate balance between incoming solar radiation and outgoing heat. In each of these cases, the first law of thermodynamics provides a fundamental framework for understanding the behavior of complex systems. However, the first law of thermodynamics is not just a scientific principle or a technological tool. It also has philosophical implications for our understanding of the nature of the universe and our place within it. At its core, the first law of thermodynamics tells us that the world is fundamentally interconnected, and that everything is connected by a web of energy that cannot be destroyed. It reminds us that the world is a complex and dynamic system, one that is constantly changing and evolving, but that is also governed by immutable laws. Moreover, the first law of thermodynamics also has implications for our understanding of the role of energy in human society and culture. Energy is a fundamental resource that is essential for the functioning of modern society. It is used to power our homes, transport systems, and industries, and it plays a critical role in shaping our economic, political, and social systems. The first law of thermodynamics reminds us that energy is a finite resource, and that we must use it wisely and responsibly. It encourages us to think about ways to increase energy efficiency, reduce waste, and promote renewable sources of energy. It also prompts us to consider the social and environmental impacts of our energy use, and to explore ways to create more equitable and sustainable systems of energy production and consumption. At a deeper level, the first law of thermodynamics also challenges us to rethink our relationship with the natural world. It reminds us that we are not separate from nature, but rather a part of it, and that our actions have a profound impact on the complex and interconnected systems that sustain life on Earth. It prompts us to adopt a more holistic and integrated approach to understanding and managing the natural world, one that recognizes the inherent value and interconnectedness of all living things. In conclusion, the first law of thermodynamics is a foundational principle that describes the conservation of energy in all its forms. It has practical applications in fields ranging from engineering and physics to environmental science and economics, and it also has philosophical implications for our understanding of the nature of the universe and our place within it. By reminding us of the interconnectedness of the natural world and the finite nature of energy resources, the first law of thermodynamics challenges us to adopt more sustainable and responsible practices in our use of energy, and to cultivate a deeper appreciation and respect for the complex and dynamic systems that sustain life on Earth. If you want to learn more about intriguing topics like this, make sure to subscribe to our channel for more thought-provoking content.